and welcome to today's webinar, 5G, What You Need to Know Today, hosted by Competitive Carriers Association, CCA, and Award Solutions. We're on the RCA platform, CCA's partner who live streams our keynote sessions at the CCA Mobile Carrier Show in Denver, April 8th through 10th. I'm Steve Berry, President and CEO of CCA. And before we get started to the meat of the presentation, I would like to give you a little background on CCA and how we are working with one of our members, Award Solutions, to bring educational opportunities to our members and industry stakeholders. Next slide. CCA is an advocacy organization made up of nearly 100 wireless carriers and over 150 associate members, the vendors and suppliers that provides goods and services to the carriers. Here's a small sampling, a logo sampling of some of our members. Next slide. CCA's main purpose is to advocate on behalf of our carrier members on issues most important to them, like access to spectrum, the lifeblood of wireless services and connectivity, streamline infrastructure policies, access to devices, universal service fund, and, of course, the pathway to 5G for rural America. Next slide. We have three main missions: advocacy, of course, education, and networking opportunities where our members meet face-to-face to share information. As technology evolves, an important part of our organization is providing educational opportunities to our members, much like this webinar today. We're very pleased to be working with Award Solutions, a longtime CCA member, to provide a unique program on one of the industry's hottest topics, 5G. Next slide. As part of this partnership, Award Solutions will be hosting a special hands-on and interactive session at CCA's upcoming Mobile Carrier Show, April 8th through 10th in Denver. We have an outstanding program planned for the show, and I would encourage everyone on the webinar to attend. If you want to meet carriers and the key decision makers from the carriers, as I always say, be where the carriers are, this is the place to be. There are plenty of networking opportunities designed to facilitate industry connections, including lunches, happy hours in the exhibit hall, and a community service project the day before the show. So please check out the website, join us in Denver. Early bird rates increase on March 8th, so register now to get the best rates. Next slide. As I mentioned, Award Solutions will be leading a session at the Denver show, the 5G integration experience. It's highly interactive on 5G, designed for all audiences, from marketers to engineers. Participants will learn the key building blocks and steps to prepare for 5G rollouts, and will hear about critical considerations for 5G use cases. I should mention this session is free. Yes, free to anyone attending the show. I hope you will attend. Next slide. I'm also pleased to announce today that CCA is launching a 5G technology certificate program with Award Solutions. Participants will have the opportunity to take online courses from the comfort of your own home or office, and you may select your own topics. Individuals that complete the online courses will be awarded a certificate and recognized at CCA's Fall Show in Providence, Rhode Island. Yes, that's right, Providence, Rhode Island in September. More information is coming soon, and we're really excited about this new educational and training opportunity. And I should mention, all CCA members get discounts. Now, for the real reason you are here today, to hear from Mark Harms, the Award Solutions on 5G and what you need to know today. Mark, I'll turn it over to you, our expert in residence on 5G.
Fantastic. Thank you so much, Steve. I appreciate that introduction. And it's our privilege as well to be working with you at the Competitive Carrier Association. So thank you so much. We look forward to the show in April in Denver and the training that we'll provide there. So thank you. Just real quickly, a little bit about myself and Award Solutions. Award Solutions is a technology training company. We have been in the technology training business for over 20 years. And we primarily do custom technology training in this space. And by this space, I mean for vendors, device manufacturers, network operators, et cetera, and any kind of technology type of companies. We provide custom training for 5G, for IoT, for 4G LTE, for AI, etc. And we're also providing custom training for digital business transformation. My name is Mark Harms. I've been in this space for well over 30 years, and I really enjoy technology. I know we have quite a varied audience here today. Some of you are highly technical, some of you are in sales or in marketing, and some of you are in leadership. I tend to focus on folks that are in a business role here at my role at Award Solutions. So I look forward to laying a foundation with you during this 1-hour webinar. I have with me my colleague, Bill Stringer, who is also one of our subject matter experts here at Award Solutions, and he may be answering some of the questions for you in the Q&A window. Thanks for joining me, Bill.
Thank you, Mark.
You bet. All right, so let's dive in today on 5G, what you need to know today. We're going to be covering several different pieces. We'll define 5G. We'll talk about what it delivers, how it differs from 4G LTE. We'll talk about the impact of spectrum and deploying 5G in different bands of spectrum. So that'll be a big discussion here today. We'll talk about applications. I really want to bookend this presentation at the beginning to think about applications, and then again at the end to come back to applications. We'll talk about the status of 5G and the deployment timelines, and then Steve has already mentioned how CCA is helping members prepare for 5G with some of these training opportunities that we just discussed. So let me start and have you think about applications, and maybe just take 5 seconds to think in your mind, what applications do you see 5G enabling? Or maybe stated differently, what applications do you see 5G supercharging? So think about an application or two in your head that you're excited about or that you've been thinking about with 5G. And then think about, what do I need to make that application a reality? So a couple of thoughts to get us going. I need some higher throughput to maybe provide some higher def video for surveillance or something like that. I need higher throughput to be able to provide a better seamless solution for fixed wireless solutions that are available. I also need a lower latency and higher throughput and network reliability for things like spatial computing or extended realities like augmented reality or virtual reality. Of course, autonomous cars comes into play here as well. And then I may need things like connection density, longer battery life, and also lower latency to make reality these ideas of smart factories or drone solutions, obviously different monitoring solutions, precision farming, or automated mining. So those are some of the applications that I want to get to at the end of the presentation, but I don't want to just focus on technology today. I definitely want to be able to dive into the implication of this technology and what applications it will enable or supercharge. Before we get into that, I just want to have a high-level view for a second. What is the industry impact when it comes to 5G? And the World Economic Forum suggests that there will be over $12 trillion spent in new goods and services by 2035, supercharged and enabled by 5G. That's a huge number. And by the way, I should mention at this point that after the presentation, you'll be able to download a PDF reference guide that'll have links and most of these slides in there for you so that you can view this information. Another key point is smart connected objects. They've said that it's the intellectual property, patents, applications, and others have soared in this area over the last 3 years. And then we've heard maybe the fourth industrial revolution, ushering in this new era of connectivity, whether that's 5G, AI, IoT, spatial computing, and other factors. But it's certainly a huge transformation that is occurring. And then lastly, fixed wireless. It's estimated that around 23 million people lack access to 25 megabits on the downlink, 3 megabits on the uplink when it comes to their broadband internet service here in the US. So this is an area that 5G will certainly have an impact on. So those are some high-level industry impacts. If you're thinking 5G is just another step up or just another G, I want to challenge that for a second with these quotes from several leaders. So you see, it's not just a step up. It's not just faster and more efficient. Instead, it's a real-time network. It will unlock capabilities. It's a quantum leap that will bring radical new possibilities across areas of technology. It's a game changer, and it'll fuel job creation, innovation, well beyond what we've seen so far. And as Steve, who just spoke a minute ago, said, The potential of 5G networks can supercharge next generation's technologies and unlock unprecedented economic, educational, health, and safety opportunities in rural America. So I do want you to consider the impact of 5G. It's going to be significant. It's not going to be just an incremental step from 4G, much like 4G was for 3G. 5G is going to be that and much, much more. So I just want to lay that foundation there. So if you would, take a second and in your mind, think about if you could define 5G. How would you define 5G in 9 words or less? Here at Award Solutions, we like to challenge ourselves to define technology terms in 9 words or less. We call them a define in 9. And we do that because we find that it makes it easier to comprehend and understand. Hopefully it makes it easier to remember. And then lastly, I hope that it'll make it easier for you to communicate this terminology to others. So our definition for 5G, we'll see how it lines up with your definition. But our definition for 5G is 5th generation wireless, providing higher capacity and lower latency. Clearly, we're focusing on 2 of the capabilities of 5G. There are many others. So we feel like this is a good way to define a technology term, not in a paragraph, but to squish it down to 9 words or less. I hope you find that helpful. Let me start by saying that 5G is not like a light switch. I don't have it, and then I turn it on, and I do. Instead, it's going to come in at least 2 phases. Phase 1 of 5G was defined by the 3GPP, the Third Generation Partnership Project Organization, in their Release 15 release that came out a while ago now. And networks are being deployed today with this Release 15 standard. In addition, that committee and that standards body continues to work on Release 16, and that's where Phase 2 will come into play. And the specifications are anticipated or scheduled to be completed in December of 2019. So when people talk about 5G, you do need to nail them down a little bit and see if they're talking about things that are capable today or things that are coming in the near future. And so I encourage you to do that. We'll separate these 2 out and make it a little clearer what's available in Phase 1 and what's available in Phase 2. If you have questions about that, please jump in the Q&A window and feel free to ask some questions. So in Phase 1, there's a few key capabilities. Let me start with saying there's some assumptions. These aren't listed in most places, but it's assumed that the 5G network is going to leverage virtualization technologies like network functions virtualization, software-defined networking, orchestration, etc. And secondly, it's also assumed that it will leverage automation, and we'll do a lot of automation in the 5G space. However, if you look at the exact capabilities that have been called out, we're providing a mobile network. We're going to have higher peak data rates, higher capacity. We're going to have lower latency and higher reliability. And again, we talked about capacity and low latency as 2 of the features that we're calling out in our define in 9. And then we're going to have something called network slicing that we won't have time to get into today. Phase 2, on the other hand, will have everything that Phase 1 has, plus some improvements. A little more focus on the connection density part. We're hoping to achieve 1 million devices in 1 square kilometer. That's pretty amazing if you think about it. So we'll see when that comes out in Phase 2. The specs, again, are to be completed by December of 2019. We'll also have more on the vehicle to everything. The URLLC stands for ultra reliable, low latency communications. And so I'll talk more about those applications that leverage ultra reliable, low latency applications, but there's some enhancements coming in 5G Phase 2 for that. And then lastly, unlicensed spectrum. And one of the spectrum bands that is an obvious candidate here is CBRS. And again, I'll mention that a little bit more in just a minute. I see a couple of questions about frequencies and NR, and I'm going to get to both of those topics in just a minute. So super. Thank you, Luke or Lakey, and thank you, Medavari, for your questions. I appreciate it. Keep them coming. Secondly, if you think about the features that were defined in Release 15, number 1 is new radio, and this goes specifically to Lakey's question. New radio, you'll see it acronymized often as NR. And so that is defining the radio access from the UE, the user equipment or the device, and the radio access network, the tower, the small cells, etc. This will define or has defined the air interface there. It's obviously flexible, obviously provides low latency. And then there's a couple of deployment options that are defined in phase one. One of those is non-standalone, and you'll see it defined as NSA. And another one is standalone, and you'll see it defined as SA. And I will address both of those deployment options in just a minute. Phase two, on the other hand, will have those ultra-reliable, low-latency communication enhancements, connection density that I just talked about, the vehicle to everything, unlicensed spectrum, think CBRS as a potential, and then other efficiency changes. And I've just summarized kind of the top 5 in each for you to try to keep this simple and straightforward. Okay, I see some other questions about deploying in different bands, and again, I'm coming to those here in just a minute. So let me talk about these 2 deployment options, non-standalone and standalone first. When you think about the non-standalone option, so today, as a wireless operator, you have a 4G LTE core, you have eNode Bs and your radio access network for LTE that's deployed and available today. So one option in deploying 5G is non-standalone. And in a non-standalone option, we deploy a new 5G G-Node B, the G there standing for next generation. And that G-Node B would be connected into the 4G LTE core and also to its peer eNode Bs. And then from this 5G G-Node B, I can provide the radio access. And you see here the acronym that I'm using again, NR. So we can provide that new radio communication over the air. So in that case, this is called non-standalone, as I mentioned, or NSA, that you'll see people use as an acronym. And in the standards, people have called it 3X, option 3X. So if you see people talk about option 3X, or if you see people talk about NSA, one of the things they're talking about is leveraging the existing 4G LTE core and existing eNode Bs, and then deploying new 5G G-Node Bs so that they can communicate to 5G devices. Just to mention it here, there's another option called option 2, and option 2 is the standalone option, and in that case, you would be deploying a 5G core network. And again, we won't get into too much on the 5G core network today, but I want you to be aware of that option that folks will pursue later. Most folks are pursuing initially this non-standalone option, and then many will be moving to a standalone option as the opportunity allows. I see an interesting question here from an anonymous attendee about the G, and I just want to highlight something real quick. 5G does stand for, in that case, the G is for 5th generation. But let me just share kind of a funny story. I was talking to my brother, who is not in this space. You'll know that here in a minute. But he was like, Mark, 5G, what's the big deal? I've had 5G in my house for a while now. He's clearly talking about a 5 gigahertz Wi-Fi router. And so in that case, know that the 5G in that case stands for gigahertz, and that comes with the new Wi-Fi 802.11ac definition. And so some people that you talk to may actually be confused between that and this 5G, which stands for 5th generation, which is the new cellular technology that's going to enable all these things that we've been talking about. So I hope that answers that question, and we'll talk about the others. I see Prakash asking about what is option 1X. Prakash, I'm not exactly sure what all the other options are. I think at one point there was about 9 different options available. What I'm seeing today in the industry is people are beginning to assimilate and congregate around these 2 options. Option 3X, which is the non-standalone option, and option 2, which is a standalone option. I hope that answers your question. I'll be glad to give you more insight on that offline. And then I see a question for Stephen about smaller operators, and you're exactly right, Stephen. I do think NSA will be most practical evolution path for smaller operators. All right, great. Please keep the questions coming. They energize me, and I love to answer them as we're going along. I see this question from Victor. What phase does include spectrum sharing? I believe that's in phase 2, Victor. I'm not positive on that, but clearly the unlicensed piece is in phase 2. So I'll have to double check that for you to see if the spectrum sharing is included in phase 1 or not. All right, super. Thanks for the questions. Keep them coming. Now, let's pause here. I've talked about what it does. We've defined 5G, and we've also talked about a couple of deployment options. I want to transition to a little bit on the hows. How does 5G achieve some of these things? We won't go into details, but I want to give you enough understanding so that you can understand when folks are talking about how we're achieving these things. I'm going to focus on two things that 5G is achieving for us. The first is achieving lower latency. So how is 5G achieving lower latency over LTE? There's actually several ways, and I'm going to just tackle two of them real quick. One of these is if we move and allow these distributed units or small cells more and more functionality, if we put more and more functionality in them or more and more responsibility in them, as they do more, they can do more quickly, and therefore that should lower the latency between the communication between the device and the small cell. The second key way is scheduling. And in 4G LTE, we tend to do scheduling in larger intervals. And when we do scheduling in larger intervals, that takes a little bit longer for the acknowledgement to get back and for us to know that we can move on to the next packet. While in 5G, we are doing scheduling, we have some flexible scheduling, some new opportunities here, and we can do scheduling in smaller intervals. And by doing that, we can get some acknowledgement back faster and therefore lower our latency as well. So that is two of the ways that in 5G we're achieving lower latency. For a minute here, let me get more specific. Typically when people talk about latency, they talk about one-way latency. Sometimes you will see people talk about two-way latency. So it's something to consider and talk about when you're having a conversation around latency. One of the milestones and specification comments is that the radio access network, specifically this link between the device and the E node B, or for 5G, the G node B, that should not add more than 1 millisecond of delay. So that's something that you see in the specs. We're not quite there yet, but we see significant progress here. So overall, we're talking about moving from tens of milliseconds of delay in LTE to single-digit milliseconds of delay in 5G. All right, so I hope that gives you a little bit of an idea of how we're achieving lower latency in 5G. Now, let me kind of take a sidestep here, and I want to talk about something else that you're hearing a lot in the industry that falls right along with lowering latency, and that is edge computing. So I like to think about edge computing as an overarching umbrella term. And so when you think about edge computing, the question is, where do I want to run my compute? Or where do I want to run my application? And so traditionally, our applications are running in the cloud, and we're moving those applications from the cloud into, or closer, sorry, to the edge. One stop where they may pause is at the mobile network operator edge. And that's called MEC, multi-access edge computing. I'll talk more about that in a minute. But in general, edge computing doesn't have to stop here. I can move my edge even further to the device or closer to the device. And one part would be putting it in the same building that the device is in. So if I have a stadium, or if I have a farm, or if I have a factory, I might want my processing to be done on site in that factory, in that farm, in that stadium. I could also move it from that site right on into the device. So fundamentally, what I'm saying is edge computing is any time that I'm moving my compute closer and closer to the device, whether that be at the mobile network operator, whether that be at the site where my device is located, or whether that be in the device itself. Now, as that is an overarching umbrella, a subcomponent of that is multi-access edge computing. And in multi-access edge computing, I provide that processing or that compute at the edge of the network operator. Just to be clear, it says multi-access, and that means that it doesn't not have to be wireless only. I could have an Ethernet or fiber cable coming out here connecting to some site as well. So it is multi-access edge computing. And our define a 9 for multi-access edge computing is processing available at the service provider network border. Notice I've said generically service provider versus saying mobile network operator, because it could also be a company that is providing wireline type services. So I'm moving that processing closer. Why am I moving that processing closer? One of the key motivations for that, as I mentioned, is lowering the latency so that I can do things more quickly, respond more quickly. By the way, there's some other reasons I might move it. You could argue that it might be more secure because the data isn't going all the way across a network. You can also do more intelligent things right on the edge and therefore respond more quickly. So those are some of the things around multi-access edge computing. All right, let me just look here a little bit at the questions. I see a question about 1 millisecond TTI from Wes, and that is correct, Wes. In 5G, there are smaller TTIs defined. One of the complicated things there, Wes, is it does depend on the subcarrier spacing, and the subcarrier spacing does depend on the frequency band in which you're deploying your network. So it's not quite as static as it was in LTE. It's a little more dynamic and flexible in 5G, but you could also argue that makes it a little more complex. I see one here saying, do you need more spectrum bandwidth to achieve real-time latency? And Jose, you really do not need more spectrum bandwidth to achieve real-time latency. Normal spectrum bandwidth can achieve this lower latency. MEC can also help achieve that lower latency. Prakash asked a similar question on the 1 millisecond. I think we're good. Yeah, are we going to use fog computing in 5G, Ankit? Ankit, the term fog computing, just for me personally, seems a bit vague. You could argue that edge computing is kind of a term of fog because I'm moving the computing where I need to, closer to the edge, a little farther away, etc. But I won't chat a whole lot more about fog computing. And then I see Prakash talking about subcarrier spacing. You're correct, Prakash. There are different options there, and it depends at what frequency band you're deploying. I'd be glad to get you some of those details later. Nilesh is asking about MEC being a reality with 5G SA, the standalone option, or can mobile operators use NSA? That's a great point, Nilesh. And I personally see most operators thinking about MEC for the SA, but technically you could deploy MEC in a NSA as well solution. But again, you begin to run into some challenges on the 4G LTE core network that's a little more static, and that's not quite as flexible with the user plane and data plane. So you really don't get the full advantages of MEC until you go to the standalone option. All right, I think I've answered several of those. There's a few more coming in. Hopefully Bill will help me on some of those as well. And if there's others that I need to address, I'll pause again in a minute. Let's talk about another key thing that we've talked about that people have been bringing up, and that's higher peak data rates. So, and the spectrum implications. So how do I achieve higher peak data rates in 5G? Well, it depends on the spectrum band that I deploy it in. If I deploy 5G in the low band, then I will be using RF channels. Technically, we call these carriers, not to be confused with a mobile network operator. And we use these today, and they're already fairly well defined as sizes of 5, 10, 15, or 20 megahertz. And that's because of the definitions in the standards body, but it's also because of what the FCC has made available in the industry as well. Midband, on the other hand, there tends to be slightly larger RF carriers available in the midband. And so there's an opportunity there to leverage these larger carriers in the midband for 5G. And then in the high band, there's another opportunity because there our carrier sizes can be quite large. We can have 100 megahertz carriers or even 400 megahertz carriers available in the high band. Today, as you know, we're doing carrier aggregation at the low band, and we can continue to do that in 5G. Sometimes you'll see carrier aggregation acronymized as CA. If I have mid-band spectrum as well, I can aggregate some of these low-band carriers as well as these mid-band carriers and get even more capacity or higher peak data rates made available to my users. And then lastly, you see the real bang for your buck here when you move into that high band. and see these huge 100 to 400 megahertz size carriers. So fundamentally, if I were to answer this question very, very simply, how does 5G achieve higher peak data rates? I would answer it by saying more spectrum. You got to use more spectrum, or use larger carriers, and that's the technical term for those RF channels. So I hope that's clear. To achieve these higher peak data rates, you need to use more spectrum or higher, larger carriers. All right, I see some more questions on SA Greenfield from Prakash. That's correct, Prakash, but it's not exclusive to Greenfield. John is when someone asks how much is it going to cost to go to 5G. That's a great question. The answer, other than it depends, that's great. You know, you could argue this a couple of different ways. Number one, it's going to cost similar to what it costs in 4G if I'm deploying in low and mid bands. It may cost more if I'm deploying in high bands because I need more small cells and more fiber. However, the interesting, complicated part here is operators have been thinking about this for a while now. And so in some cases, they're already achieving or you know, leveraging more fiber and more small cells. All right, and then I see another question from Steve actually on higher peak data rates. Does that also mean higher capacity? And it does. So let me use that term loosely for a minute, that higher capacity can be achieved by using more spectrum or having larger carriers. In some cases, you see people defining capacity and they add a per megahertz piece. And so I would say that in that case, having larger carriers does not help you if you're defining capacity as an efficiency metric and having a higher throughput per carrier or per megahertz. But if you're just overall defining your network and what capacity your network has, absolutely, you get much higher capacity by doing this. All right, let me keep us going. If there's other questions, I'll be glad to jump in there and answer them along the way. Thanks, Bill, for answering some of these off the bat. So when it looks at spectrum, you got low band spectrum. Today, we talked about that. Here are some of the low band spectrum bands available. We have mid band spectrum, several of these available today. I'll just highlight that two are really gaining traction. One of those is CBRS, and the other one is satellite C-band. When it comes to CBRS, we actually anticipate seeing something there this first half of 2019. I think the government shutdown had a little bit of a delay on that. It could be as early as this quarter, it could be next quarter. So CBRS will soon be a reality, and CBRS has both licensed and unlicensed bands. We'll start by using the unlicensed blocks, and then later they'll have an auction for the licensed blocks. And then if you go much further up on the spectrum chart, you get into the high band. And most people are calling this millimeter wave. Why? Because it's literally millimeters wide. So I think the 28 gigahertz is somewhere in the range of 9 to 11 millimeters wide. And that's where you find these large swaths of spectrum. However, the propagation for that spectrum is not as good. So there's some pros and cons when it comes to millimeter wave that I'll dive into here in a second. I just want to mention this real quick for you. You'll see people talk about FR1. This is defined in the 5G spec, and I believe that stands for frequency range 1, and that's for frequencies less than 6 gigahertz. And then for frequencies above 24 gigahertz, they call that FR2. And someone was asking about the subcarrier spacing, and the subcarrier spacing options differ depending if you're deploying in FR1 or if you're deploying in FR2. All right, fantastic. Let's dive into the implications of deploying in low, medium, or high band spectrum. First of all, in low band. When you deploy in low band, you're going to get pretty good coverage because, as you can see in the picture here, the spectrum, the actual radio frequency wave, is pretty long, and therefore it propagates pretty well and it penetrates buildings pretty well. And just like in 4G LTE, where we can use things like 2x2 MIMO, multiple input, multiple output, or 4x4 MIMO, multiple input, multiple output, which many operators are deploying today here in the US, we'll be able to do similar things with 5G as well. Now, if I deploy in midband, since my spectrum is a little smaller, the propagation isn't as great as in low band, and therefore my coverage will be a little less, and therefore I'll need more towers or small cells to do that. However, I get an advantage because I can deploy and leverage more antenna elements. And in certain mid-band ranges, I can begin to use something like 64 different antenna elements. And we hear Sprint doing this today in that 2.3, 2.4 gigahertz range. And that gives me some unique advantages as well that I'll talk a little bit more about in the high band. When I go to the high band, notice that my carriers are much larger because there's much more spectrum available there. I may have 100 megahertz carriers or even 400 megahertz carriers. That is where the highest size of carrier defined in 5G versus the highest carrier defined in 4G LTE is 20 megahertz. The other thing with high band is I can use a lot more antenna elements. So people are talking about 512, 1024, and this allows me to do some very fancy things around beamforming, and I can follow certain devices as they move through my cell sites, etc. And I can do some different streams if I want. Now don't get crazy, I can't do 1024 streams, but I can do a few more streams. And so there's a lot of flexibility here. The downside, obviously, is that since this frequency is so small, it propagates a lot less, and therefore I will need more small cells. Now, having said that, let's talk about the capacity, overall capacity improvements. And again, I'm going to provide you some rough numbers to give you an idea, but these can vary depending on several other factors. So first of all, if I'm deploying 5G in low band, I can expect to get somewhere between a 10 to 20% improvement. There are some new things that we do in 5G, some new coding techniques and a few other things that allow me a gain, but that gain is a 10 to 20% improvement. When I look to deploy 5G in mid-band, the improvement, by the way, is over 4G LTE, sorry, just to be clear there. When I look to deploy in mid-band, because I'm using a lot more spectrum and I can have higher, larger RF carriers, I can get 2 times to 4 times a capacity improvement. And again, a lot of variables here, including my carrier sizes and how many carriers. And then finally, in the high band, I can get maybe 10 times capacity improvement or maybe even more. Again, it depends on how many bands I'm aggregating here, and it depends on how large those bands are. But clearly, to achieve these higher capacity and therefore also higher peak data rates, I want to use more spectrum, and more of that spectrum is available in the mid-band and in the high-band areas. All right, I see several questions here. Let me just see if there's any that I want to jump on. URLLC require more spectrum or larger carriers? That's an anonymous attendee. The answer is no. URLLC does not require more spectrum or larger carriers. I can do that at relatively small carrier sizes. What are the speed users can expect on low band frequencies? I think I just answered that, Neil. Roughly 10 to 20% improvement over LTE. Impacts of the Huawei ban in 5G. I'll let Steve or Lucy handle that on the Q&A. Do you see staying with typical 3 sectors with beamforming from Jerry? I believe so, Jerry. I think that's going to continue to be the case. Improvement in capacity. I think we've answered that, meaning X simultaneous users per slice of spectrum. Yeah, that's one way you can look at it, John. Overall capacity improvement. How many users can I use and what can I give them? And then I see Prakash is sub 6 gigahertz, all FR1. That is correct, Prakash. All sub 6 is FR1. All right, I probably missed a couple in there, but I hope I answered many of those. So please keep them coming. I love the questions. All right, since most people are talking about, I shouldn't say most, since many people are talking about deploying 5G with high band, sometimes you've seen people tie these two tightly together. Right? I can deploy 5G at low band. I do not have to have that high band millimeter wave spectrum to deploy 5G. I want to be really clear about that. 5G does not equal millimeter wave. However, if I want to take full advantage of this high capacity opportunity, I want to use more spectrum. and the larger swaths of spectrum are available in that high band. So it's a natural place for people to migrate to and leverage. If we do that, because the propagation of these carriers is a little less, then we're going to need many more small cells. And with that, we will need more fiber running to those small cells. And therefore, that's a direct impact, if you will, of leveraging that high band. So that is why you see folks like Wells Fargo in their analyst report talking about a dense fiber footprint, distributed small cells, new spectrum bands, and edge compute. They see all that as critical to 5G live. Of course, you don't have to have that high band, like I said, to be 5G. But if you want that higher capacity, you need at least some of that mid band and potentially high band to achieve that. And Orange here is talking about 3 key components that they see: high-speed mobile broadband, high-speed fixed broadband, and then new uses, including connected objects. So you see a lot of talk around IoT and the connection density that we're going to be able to achieve there. All right, very good. Let me talk about a quick comparison here, and then I'm going to end with some applications, and then we'll take some Q&A at the end here. So when you compare 4G LTE and 5G, first of all, there are some similarities. We did not define a new radio access technology. So we're still using OFDMA, orthogonal frequency division multiple access. And that is what we're using in LTE, and now we're using that in 5G. Now it's different. It's much more flexible. There's several things that are different about it, but it's still OFDMA. Both of them can use many different spectrum bands. And lastly, initially, they may both use the same 4G LTE core. So I wanted you to know about that. The differences are several. So in LTE, the max radio frequency channel size that's defined in the specs is 20 megahertz. So that is the maximum in 4G LTE, while in 5G, the max size is 400 megahertz. So that's a huge difference. That's a 20 times difference, to be precise. And that's one of the areas where we can gain that huge capacity gain. In addition to that, 4G LTE offers latency in the tens of milliseconds. I mentioned this earlier, while 5G offers lower latency in the single-digit millisecond range. We're trying to achieve 1 millisecond. That's the objective. I don't believe that will be met immediately, but that is the objective as we move on. And then finally, the 4G LTE core is clearly less flexible. One of the things I don't have time to get into now, but I'll just mention for you, is the 5G core is very flexible, and it allows for user plane and control plane separation. And this will allow for some unique ways to deploy applications. This is also something that will help with multi-access edge computing, or MEC, as well. So I hope that makes sense. All right, let me end with some applications. What applications does 5G enable? I've talked about some of these at the beginning, and I just want to highlight a few of them individually and get your mind thinking about these applications, many of which are directly applicable in rural areas. Higher capacity. Higher capacity is going to enable, one of the things it will enable is HD video. I can leverage this HD video in surveillance scenarios and telehealth and many other scenarios. So having this HD video, this higher capacity, specifically, by the way, in the uplink, is a huge advantage in 5G. Fixed wireless goes without saying. Higher capacity enables me to offer users a fixed wireless experience that is much better, potentially much better than 25 megabits, even 100 megabits or more. Potentially we can get up to the 1 gigabit per second. And in fact, you see different operators already experiencing different benefits through this. I just will mention quickly, there's some recent development with C Spire, and they're providing some additional fixed wireless solutions, and they're using a proprietary technology to achieve that. So I would not say that it is release 15 specific. However, since they do meet some of the ITU requirements, you could consider that it is a 5G type of technology. but just to be clear, it is not a release 15 or phase 1 compliant piece of technology. But again, that's really, who cares, right? If it delivers a service that you want and it's delivering it in the way that you want it to be delivered, that's what matters. So that's that. On other applications, capacity plus low latency can enable drone applications, and that drone applications I can leverage for surveillance, for inspection. I think this could have some interesting implications as well in rural areas where I have large swaths of land that I need to inspect, or different machinery that I don't want to go out to see every so often, or it's hard to get to. I can leverage some drone opportunities there. One that you might not immediately think of as applicable in the rural communities is this spatial computing, and high capacity and low latency can enable this. Things like augmented reality or virtual reality or mixed reality. But a couple of scenarios that may come into play here is if I have a technician who is working on a combine or an advanced precision farming device, or a mining device, or even a smart factory that has some devices, and that technician can put on these virtual reality or mixed reality goggles and hopefully connect with an expert technician back at HQ, and that expert technician can see what they see and in fact write or draw on the specific piece of equipment that they need to inspect or modify or change, and that may enable this local technician to accomplish more. So that's one area where this spatial computing piece may actually fit in. Smart factories, I believe this could be a huge opportunity. The ultra reliability and low latency functionality enables smart factories. And this is I'll bring up a point here that I read in one of the reports, but the report was talking about thinking at a micro level. So I encourage each of you, specifically the mobile network operators, to think about, I may not be deploying 5G to cover my entire area, but I may have a couple of manufacturing areas. And maybe I need to partner with a couple of them and deploy 5G, especially if we talk about this non-standalone option. I can deploy some 5G cells relatively straightforwardly to cover a couple of key factory areas, to cover a docking station or a shipping corner or whatever the case may be. And so I can do some spot opportunities here and really leverage this ultra reliability and this low latency. Same for precision farming, same for automated mining solutions, etc. So I think there's a lot of opportunities for these applications in the rural space. Great. As I finish, I just want to make you aware of a triangle on usage scenarios that the ITU has published. You may see this triangle in different places. And in that, they talk about 3 different edges, if you will, for applications. One is massive machine type communication, or MMTC. And remember, I mentioned we're looking for possibly having 1 million devices in a 1 square kilometer location. That's a huge, densely amount of devices. Another that I've talked about is this low latency and high reliability, or URLLC piece. And then another is the enhanced mobile broadband. And then if you just lay in applications in here, applications may require 1 or more of these. So this isn't like they all belong on this corner of the triangle or this corner of the triangle. Sometimes they need a little bit of each one of these. And so I've just laid out some of the applications here to help you think through what application requires higher capacity or higher peak data rates and mobile broadband, what application might require this URLLC, and which applications may just need this massive machine type. Think more of the IoT type of devices. So thank you so much for attending this session. I really do appreciate it. As Steve said, we look forward to seeing you at the Mobile Carriers show in April in Denver, and we'll be there presenting this 5G integration experience. We do have about 10 more minutes here in the session, so I think we've answered many of the Q&A questions, but if there are other questions that Ben or anyone else wants to read out, if you have other questions, please feel free to do that. Actually, I just remembered one more thing. At the end, you'll see a PDF that you'll be able to download, and this PDF has many of the key slides. I'm just scrolling through it real quickly here for you. And so you'll be able to download that PDF here in just momentarily. And it has a lot of links as well to many different things, including the mobile carrier show in April. So you can click on that and that'll take you there. So you'll be able to download that PDF. All right, let me open it up for questions and see if you guys have any questions. I hope you found that presentation useful.
Thanks so much, Mark. I really appreciate it, and thank you for going through a lot of the questions while you were doing your presentation. A couple questions. One, our friend over at John Deere suggested, how is 5G going to here? You're moving too fast. How's 5G going to help my combine if there's no coverage now in areas of the cropland? That's something we live and die for over here at CCA. Would you like to respond to it, Mark?
Yeah, it's a great question. And clearly, if there is no coverage, then 5G is not going to provide help. The thing I would mention here is that one of the things that we'll see happening in 5G is the opportunity to use any of these bands of spectrum. So if I want to choose to use a low band spectrum and therefore provide a coverage scenario for some of these larger farms, rural communities can do that, rural operators can do that and leverage 5G in that low band. In addition, they may choose to partner with some folks and provide spot 5G just for certain smart factories, farms, etc., and even use some of the high band spectrum there, depending on the scenario, the application, and if those much higher peak data rates are required. I hope that helps.
Thanks, Mark. Yeah, and I would suggest that any of the farmers out there trying to get to the back 40, get to know your rural wireless carrier that serves that area. We have many of the small carriers out there are willing to build out their network for an anchor tenant. And in many of those areas, the farmers are, in fact, the preferred anchor tenant. Real quick, backhaul. What's the questions abound on backhaul? What's the type and how it will be used? And backhaul, fiber, wireless, microwave. Could you comment on that, Mark?
Absolutely. So there's some interesting things in 5G when the architecture evolves that we probably don't have time to get into. If I start simply by saying that the backhaul that I'm using today for 4G LTE, if it's fiber-based, I'll be able to leverage that same backhaul for 5G. In addition to that, I can certainly use microwave for backhaul. But there's some architectural changes that if you're more technical, you may know about the distributed units versus central units. And if you do that, you have an additional piece called a mid-haul and then the front haul if you're centralizing these. And therefore, your whole hauling of that data back would get a little more complex, but still leveraging many of the technologies that we do today, like fiber and microwave.
Thanks. Another question, power. Several questions on power. How does 5G improve power consumption on the network and the user end? Why is it less power?
Perfect. So that's not my area of expertise. I'll give you my simple answer, and that is because of the normal Moore's law and the effects happening in compute, and therefore I need less and less power to run more and more powerful computing engines. Because of Moore's law. There's probably other things that I'm missing there since that's not my area of expertise.
Another one, beam tracking. How will it be deployed, when it will be deployed, and how does it work?
Perfect. That one's an interesting one. We could do a whole class on beamforming and tracking, and fundamentally we use a subset of these antenna elements. You can think of it as instead of using your low beams on your headlights on your car, which spread the light energy over a wide area, I would use the high beams, which focus that light energy. In our case, obviously, I'm talking about radio frequency energy or RF energy. And these beams can focus that RF energy on precise points and therefore enable me to have some unique coverage expansion, some unique tracking as well of devices. And that is something that people are making significant progress on. And I think we'll see some scenarios of that later this year.
Another question, modulation schemes. What's the most prevalent? What will be used? And what do you think will be the first deployment schemes, modulation schemes around the first 5G deployments?
That's a great answer, a great question. And I wish I had a really good answer. I'm assuming, and this is an assumption, I do not have that knowledge right now, but I'm assuming that we would be using 256 QAM like we're using in 4G LTE Advanced Pro, but I'm not 100% sure about that one.
Okay, we'll take that one.
Real quick here, Steve. I saw one comparing, they were confused about NR versus G node B, and they were asking if that's the same thing. I can't seem to find that question now, but remember, NR stands for new radio. So when it comes to new radio, that is correct. I would deploy that new radio interface with a G node B or a next generation node B. So whoever was asking that question, I hope that answers that.
Okay, fixed wireless. Why are most of the new innovative wireless deployment networks in the United States using unlicensed spectrum versus licensed spectrum?
Okay, good question. Why are they using unlicensed versus licensed? Was that the question?
Yes, I think what they're getting at is many of the providers of the new innovative solutions are smaller companies, not totally compliant with the license requirements of the 3GPP. I think that's the answer if you want to comment.
Yeah, that's correct. I mean, I think part of the challenge with licensed spectrum, obviously, is the cost. In some cases, and I'll just point to a couple, if you think about C Spire, they already had some, I believe it's 28 gigahertz licensed spectrum, and others may have some of that as well. That auction, by the way, just finished a few weeks ago for additional swaths of that spectrum, and I anticipate that some rural carriers came away with some additional 28 gigahertz licensed spectrum. But the beauty of unlicensed is it allows me to jump in on unlicensed bands without the cost of buying the spectrum or winning it at auction, number one. And number two, the major downside to unlicensed bands is that if someone else is using them, they cause interference. Well, if I'm in a rural area and I know what people are doing in that area, I'm less likely to run into scenarios where that unlicensed band is being interfered with. That's especially true if it's a smaller geographic area. So it makes a great way to jump right into the deployment of 5G, leveraging unlicensed. Now, to be clear, the unlicensed deployment of 5G is part of phase 2, and therefore those specs won't be completed until December of 2019.
All right, real quick, we have time for a couple more questions. One is about in-building microwave deployments. Is the propagation problems with millimeter mean that you'll have base stations in every room, and how does that affect the efficiency of the utilization of the network if everyone has to have a base station? Could you talk a little about in-building microwave millimeter?
Yeah, that's a great question, and that's one of the challenges with millimeter wave, no doubt about it. That is an issue. And so depending on your building, depending on your factory, depending on what you have in there, you're going to need a different number of base stations for that coverage, because that millimeter wave will not penetrate certain buildings at certain distances. Again, it penetrates some, it depends on the material, it depends on the distance, it depends on the power. There's several different factors there, but that is a key factor. I will just say quickly that there are enterprises, factories, and others considering this as opposed to Wi-Fi, because 5G and even LTE are more efficient than Wi-Fi, and 5G and LTE have better propagation characteristics than Wi-Fi, and you can still get away with less access points, or in this case, small cells versus the Wi-Fi access points. But in any case, if you're deploying 5G and millimeter wave, the propagation challenge is real. You can see some of the things that Verizon has published publicly about the ranges that they're seeing in their coverage in their fixed wireless solution that they're providing to get some ideas on that. But it's clearly an area of concern with millimeter wave. So that huge gain of a 400 megahertz channel does come at a cost.
Real quick, we'll combine a couple questions here. Devices. One, will all 3G, 4G, LTE only devices cease manufacturing in the next few months or years? And when will all devices be 5G capable?
All right, great question. I'll give you, again, this is probably a little bit beyond my scope. I'll give you my personal opinion. that in the near future, yes, I do believe 3G will continue to trail off. In the near future, mid-future, and maybe even long-term future, I do not see 4G trailing off at all. 4G LTE, 4G LTE Advanced, 4G LTE Advanced Pro, these technologies, still have quite a long life. And if you were to pin me down and have me give you a number, I would say, it's still in that 3, 5 to 10 year period. So it's still a long ways to go. One of the questions that I see is, will it handle voice? And the answer is no initially. So therefore, I'm going to use my 4G LTE and VoLTE solution for voice. And then you mentioned, when will all devices support 5G? We're still a little ways away from that. We haven't seen a device other than pucks, if you will, that support a hotspot scenario. We should see devices. I anticipate announcements this month and next, especially at Mobile World Congress. And I anticipate we'll see many more devices in the second half of this year.
Thank you. I am told we have approached the bewitching hour, so to speak, and we're going to have to call it a close. Hopefully, we didn't get to some of the NB-IoT issues, but hopefully if you come to the show, Mark will give us all you need to know on that also. Number one, thank you for your presentation, Mark. Thank all those who joined us. Thank RCR and Award Solutions for partnering with CCA, and thank you for your attention. Hope you have a good evening.
Thank you, everybody. I appreciate it, Steve. Thanks for all the questions, folks. Don't forget to download the PDF, and I hope that this has been super helpful for you. Thanks.